Factor down this quadratic top and bottom. Factor down the x squared minus 9. Factor down x squared minus 7x plus 12. So now that it's factored, what do you notice? What's going to happen? What does something cancel out?
There's a hole, yeah.
There is a hole, so we can cancel something out. This cancels out. So because I can cancel out a factor, that means I'm going to take that factor that canceled, which is x minus 3, set that equal to 0. I have a hole at x equals 3, and don't let me forget to put that on the graph. So for the remainder of these questions, we're going to use y equals x plus 3 over x minus 4. I'm using the function that I got after I canceled it out. So roots, that's the numerator. Take that x plus 3, set it equal to 0. So you have an x-intercept at -3, 0. Go ahead and plot that point. Plot a point at -3. I'm going to do it in blue, actually. Yeah. Where do you look at for your vertical asymptote? Denominator, set that equal to 0. Draw in a vertical asymptote at x equals 4. So I'm going to draw that in. I like to use 2 different colors. So I put my asymptote in a different color. So I'm going to put that in red. All right, you're in behavior. Is this top heavy, bottom heavy, or balanced? Balanced. So you're going to divide 1 by 1. So y equals 1 divided by 1, or y equals just 1. Go ahead and draw that in. And then your y-intercept. To find your y-intercept, you're going to plug 0 in for x. So again, I'm using this. Plug your 0 in here. So what's written as an ordered pair are your roots and your intercepts. And then written as an equation are your asymptotes and your EBA. So -3/4 is just a little bit above -1. Put that on my graph. We really don't have a lot. We got a lot of empty space in here. So this is where you're going to make your little T-chart. And what are some numbers that we should plug in? 5. I would definitely plug in 5. And 8. Let's go ahead and do that.
Close to the right.
Yep. Because we don't have anything on the right side of the vertical asymptote. So you're going to plug it into this equation. So take a minute. Find your 2 numbers. Plug a 5. So 5 plus 3 over 5 minus 4. 8 plus 3 over 8 minus 4.
If your 2 points were on the right side, you would find 2 on the left side to plug in, right?
No, actually, in my last class, we plugged in 2. You can plug in any numbers. But I definitely want to plug in, I would definitely plug in numbers on the right. My first period class, we plugged in 3, 5, and 8. So at this point, you really can't go wrong. You can plug in any number you want to until you have enough points that you're satisfied that you know what the graph looks like. So when you plug in or substitute is the mathematical word. When you substitute in a 5, so that would be 5 plus 3, which is 8. 8 divided by 1 is 8. Who got 8 for that first point? All right, let's go ahead and put a point at 5, 8. And then when you plug in the 8, okay, 8 plus 3 is 11. So 11 divided by 4 is going to be a decimal. So that's about 2.75. So which is right above your horizontal asymptote. So at the 8, we're going to go to 2.75. Which is right under the 3. All right, so now we're ready to draw this in. Go ahead and draw. Remember, you're going to get really close to the asymptote, but not go past it. And let's not forget our hole. We got to put a hole on the graph at positive 3. So positive 3, I'm going to put a hole on, let's see, positive 3, so that would be at about right there. I really should erase it. Let me erase it, but with this graph, I have to, okay. So we have a removable discontinuity at x equals 3 and an infinite discontinuity at x equals 4.
Is that something we'd have to label? Or just like you're stating that? Just like...
Oh, yeah. Well, I'm just telling you. It could be.
Oh. Like you don't know...
What the test looks like?
Yeah.
All right, so now let's talk about top heavy and bottom heavy. So really quickly, now we're going to backtrack to example 6 and 7. So bottom heavy, that means you have a higher exponent on the bottom. So if it doesn't have a constant added, it's just going to be y equals 0. So for this one, this is just y equals 0. But this is a special case because we have this fraction and we have the minus 4. So in that example, it would be y equals, this equals 0. That has an asymptote of 0, but now we have to include that minus 4. So that would change our asymptote to y equals negative 4. But the main thing to keep in mind is if you don't have a constant added and there's a higher exponent in your denominator, it's just going to be y equals 0. And we'll graph, well, we don't have to graph it, you'll just have to state it, and we'll get to that towards the end of the class.
That high exponent denominator
Is bottom heavy.
It's for the y intersection.
That is your horizontal asymptote, or your in behavior asymptote. Now, what if it is higher in the top? Let's look at example 7. If it's higher in the top, we have to do synthetic division with the L. I'm gonna make my little L. So you're gonna set that equal to 0. And when you set that equal to 0, if x plus 2 equals 0, that means x equals -2. Put that -2 right here. And then here, you're going to list the coefficients of your numerator. So for this example, I have a 1 in front of the x squared, a 1 in front of x, and a 3. So go ahead and list those numbers, 1, 1, 3. Who remembers how to do synthetic division? Go ahead and try to do it. Bring down that first number, multiply, and add. So we bring down that first number. And then 1 times -2 is -2. You add, you get -1. Multiply, you get a +2. You add, you get 5. This is not a factor, so we don't expect to end with a 0. So what this represents, this is the slope of your slant, and this is your y-intercept. This number means nothing. We don't use that number. It's just the first two numbers. So this graph is actually a linear equation, and it would be at y equals 1x minus 1. That's the equation for the slant. You only have to do that when it's top heavy. So now that we talk about those different asymptotes, let's go ahead and go to page, or go to example 11, and let's go ahead and graph that out. Okay, so let's factor our numerator. We always start with that. If something can factor, you always start by factoring. That will always be the first step. So go ahead and factor down that x squared plus x minus 6. So you need two numbers that multiply to be -6 and add to 1. What numbers multiply to give you -6 and add to 1?
3 and -2.
+3 and -2. Okay. Does something cancel out?
No.
Nope. So we don't have a whole. I have two x-intercepts because now I have two factors. Both of these need to be set equal to 0. So go ahead and plot both of these. So for my first one, if x plus 3 equals 0, that means I have an x-intercept at -3. And if x minus 2 equals 0, I have an x-intercept at +2. So let's go ahead, plot both of those points. Your vertical asymptote comes from your denominator. So that would be x minus 1 equals 0, x equals 1. I'm actually going to draw that in red because that's my asymptote. Go ahead and draw in a vertical line. That's the line that the graph cannot cross. Okay, so is this one top heavy, bottom heavy, or balanced?
Top heavy.
Top heavy. So we need to do synthetic division. So you're going to put that 1, when you set this equal to 0, put the 1 on the outside. And then when I look here in its unfactored form, what are the coefficients? I have a 1, and a -6. So go ahead and put 1, 1, -6. Do your synthetic division. Bring down the first number, multiply and add. We already know the slope is 1. We're really just trying to find our y-intercept. So I bring down this first number, which is a 1. 1 times 1 is 1. Add, you get a 2. You don't need to continue, but I always do. So again, this first number is your slope. This is your y-intercept, and this we don't need. So the equation for my slant, because this is a slant, is y equals 1x plus 2. Raise your hand if you remember how to graph a line. Y equals x plus 2. All right, you start at the y-intercept. So what is my y-intercept? What is B? 2. So I'm going to switch to red because this is an asymptote. I'm going to put a point at 2. My slope is 1. I'm going to zoom in really close. So you start at B, and then your slope tells you how to move. So because my slope is 1, I'm going to go up 1 to the right 1, put a point. Up 1 to the right 1, put a point. Up 1 to the right. Who remembers how to graph? Is it coming back to you? Now, you don't really need to put a lot of points, but because I'm graphing on an iPad, I can't use a ruler to make a straight line, but you all can. You can put a ruler down on your paper and make a straight line. You want it to be straight. So that's why I'm using a lot of points. Okay. Yep, if you look back at our other graphs, the asymptotes always cross each other.
Oh, it's also dashed.
Yes, it's an asymptote. This is not part of the graph. It's an asymptote. I mean, you can, but it's an asymptote. When I do the actual graph, I'm going to put arrows. I just haven't finished the graph yet. All right, so now let's find our y-intercept. So to find your y-intercept, you're going to substitute a 0 for x. And it doesn't matter which format you use. I think I'm going to use this format, though. So that would be y equals, and it'll be 0 squared plus 0 minus 6 over 0 minus 1. So that's how you find the y-intercept. And you should get 0.6, but you can go ahead and make sure that's what you got. Okay. So I'm not going to, now this is probably when you would probably plot some more points, but because of time, I'm not going to. We're just going to finish out this graph by connecting the points we have, and just keep in mind that you cannot go past your asymptotes. So I'm going to kind of roll up my slanted heel, hit my first x-intercept, go through my y-intercept, and then go straight up the wall. I am adding arrows on that part because that's the graph. And then on the other side, I mean, you could technically plot in points, but because of time, I'm not doing that. But you could put in 4 and 8 if you wanted to. But I just know that on this other side, it's going to be really close to the wall. Hit that point, and then it's going to curve up and just roll along my asymptote. And that's what your graph looks like. So we're going to skip over 12 and look at 13 next. For these last few functions, we're not going to graph them. We're just going to find the key information about them. So if you look at your purple paper, we talk about a special case. This is a special case. So when we look at number 13, this is what we call a special case because it's not just one fraction. So we have to treat things a little differently. When it's a special case, that affects the horizontal asymptote, and you have to treat your x-intercepts differently. Okay, so we'll start with our vertical asymptote, which is still going to come from your denominator. So you're going to take this x minus 3, set that equal to 0. You have a vertical asymptote at x equals 3. This equation, because we look at our degree, this is balanced. This is a balanced function. Because it's balanced, we don't have a slant. Only top heavy has a slant. I'm going to do all the easy stuff first. And then how do you find your y-intercept? What do you have to do to find your y-intercept? Substitute a 0 for x. Let's do that. Go ahead and substitute that in. This is my y-intercept that I'm trying to find right here. So you're going to write that as an ordered pair. It's going to be 0 something. So take a minute. Use your calculators if you have to. If you don't recognize the number, feel free to use your calculator. Type that in. You should get -2. Who got -2? Okay. So now this being a special case, and again, if I were to take this away, if I took away this -2, it wouldn't be special anymore. If it was just a fraction, that's not special. This is a fraction -2. That's why it's special. We got to treat it differently. Let's start with the horizontal asymptote. So for my horizontal asymptote, because it's balanced, I'm going to divide my leading coefficients, which would be y equals 1 divided by 1, and you have to subtract that 2. You can't ignore that 2. So instead of it being just y equals 1, we have to subtract the 2 from that. When you type this in your calculators, you should get that that is y equals -1. 1 minus 2 is -1. So that's a big cause of confusion when you take your test. Make sure you're paying attention to a special case versus a normal fraction. Or versus a single fraction, I should say, not a normal fraction. All right, and then for your x-intercept, instead of you looking at the numerator, is what we normally would do, we have to set this entire fraction equal to 0. So 0 equals, and it's x divided by x minus 3 minus 2. We need to solve this for x. This is how you find your roots. So we're going to start off by adding the 2. So that would be 2 equals x over x minus 3. Put this 2 over 1. Cross multiply it. So you have 2 times x minus 3 equals 1x. Go ahead and solve that for x. Okay. Go ahead and check your answers against mine. Try to zoom in a little bit. So I got 6. Who got positive 6? You can go ahead and check your work. So I want you to try to do a special case by yourself. So skip ahead and try to do number 15 all by yourself. So that one is just like 13. So I can give you 3 minutes, 4 minutes. So everyone should be working on question number 15. See how far you can get that done. So I did get a fraction for your x-intercept, so don't think you're wrong if you get a fraction for your x-intercept. Okay, you can go ahead and check your answers against mine. So again, I think the tricky part are just these two. Who's got at least 5 right? 5 out of 5. Okay. Or 4 out of 5. That's not bad. Which one did we miss?
How do you know horizontal and x-intercept?
Wait, what did you say?
Horizontal and x-intercept.
Yeah.
Oh, yeah, those two are tricky. So for horizontal asymptote, you have to take into account that because this is balanced, I'm going to start by dividing my leading coefficients like I would normally. So I'm dividing the 2 by the 1. But then I can't ignore this plus 4. So I'm dividing 2 by 1, and then I'm adding 4. So 2 divided by 1 is 2, and 2 plus 4 is 6. And then for your x-intercept, whenever it's not a single fraction, we have to set it equal to 0 and solve for x. All right.
What if you didn't reduce the fraction for the x-intercept? We left it as 4, 6 instead of 2.
That's okay, I guess. All right, I got time for one more question.
How do you know that there's no slant?
Oh, because it's not top heavy. Yeah, if your degree is the same, it's balanced. So if this was 2x squared over x minus 1, that's different. All right, so I want to finish it out. So we only have time to do one more. So I think I will do number 14. So let's look at 14 because that one is pretty straightforward. So we'll start off with factoring your denominator. Always start by factoring. That should always be your first step. Go ahead and factor your denominator down for 14. Two numbers that multiply to be -2 and add to -1. -2, +1. This is a single fraction. So there isn't like a +3 on the outside. It's just one fraction. This is not a special case, so it's straightforward. All right, vertical asymptotes always come from your denominator, but now we have 2. This is a vertical asymptote, and we have another one. We have 2 vertical asymptotes. Set both of those equal to 0 and write them as equations. Vertical asymptotes will always come from your denominator. And yes, you can have more than one. So my first vertical asymptote is at x equals +2. And my second one is at x equals -1. Is this top heavy? No. So that means we don't have a slant, so we can say none. We don't have a slant because it's not top heavy. Now, this is a bottom heavy one though. Bottom heavy ones are always going to have y equals 0 as your horizontal asymptote. We don't have to do any synthetic division. We don't have to do any division. It's just bottom heavy, so it's y equals 0. All right, your x-intercept comes from the numerator. And the only thing you have in the numerator is an x. And when you set that x equal to 0, you get 0. So your x-intercept is 0, 0. And this is from the numerator. And then lastly, go ahead and find your y-intercept by substituting a 0 in for x. That's always the definition of a y-intercept. So that would be y equals 0 divided by 0 squared minus 0 minus 2. Hopefully you don't need to actually type this in your calculator because 0 divided by anything is going to be 0. So your y-intercept is also 0, 0. So tomorrow you need to watch the video if you haven't already. I'm gonna